Welcome back to RR Max episode 2. We are continuing with the definite integrals. We will see problems today, which are most of them are standard problems using the properties mentioned in the previous episode. Questions will always be evaluate the following integral. And the first problem that I take is integral 0 to pi by 2 sin x to the power of 3 by 2 divided by sin x power 3 by 2 plus cos x power 3 by 2 into dx. Now we usually call the integral as I. Always define the integral, given integral, to be evaluated as capital I. Once you call this as I, we use the property 4, which says that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. That means I'm going to substitute my upper limit. Now we have the limit 0 to pi by 2, so I will substitute the upper limit. So instead of x, we will substitute pi by 2 minus x. So the same integral I can be rewritten as integral 0 to pi by 2 sin to the power of 3 by 2. Instead of x, I will write pi by 2 minus x. Same way in the denominator, sin to the power of 3 by 2 into pi by 2 minus x plus cos to the power of 3 by 2 into pi by 2 minus x integration with respect to x. Now sin 90 minus x is going to be cos x, and so the numerator becomes cos to the power of 3 by 2x. Similarly, the denominator is cos to the power of 3 by 2x, and cos of 90 minus x is sin x, therefore plus sin to the power of 3 by 2 into x dx. Now first given integral I is in terms of sin x power 3 by 2 in the numerator, and now we have converted as cos to the power of 3 by 2 into x. Now let's add the two integrals. So I get I plus I, which is 2I. Now the integral limit is the same, so integral 0 to pi by 2. Integration is with respect to x, so you can just add the two integrands. Now the denominator is common, so the denominator here is sin to the power of 3 by 2 into x plus cos to the power of 3 by 2 into x. Now numerators can be added. So numerator becomes sin to the power of 3 by 2x plus cos to the power of 3 by 2x into dx. Now the numerator and denominator cancels to give you 1. So the integrand reduces to just in dx. So integral 0 to pi by 2 dx. Integrating, you get x. Limits varying from, I just use a slash and you write your limits 0 to pi by 2. Upper limit is pi by 2. So first you substitute that minus the lower limit, which is 0, and therefore it is pi by 2 minus 0, which gives you pi by 2. So we started with 2I, we got an answer, numerical value is pi by 2, but I need only I, and therefore I is, you divide by 2, and that gives you I is equal to pi by 4, and that is the answer for the given integral. Let's see the second problem. I started with I is equal to, but generally in the question paper they don't give it as I. They will only say integral 0 to pi x sin x whole divided by 1 plus cos square x into dx. So you call the integral as I, and again using the same property, because the lower limit is 0, upper limit is pi. Instead of x, you change it as pi minus x. So same I is equal to integral 0 to pi. First x becomes pi minus x, then sine of pi minus x divided by 1 plus cos square of pi minus x into dx. Now we'll simplify this. That gives you integral 0 to pi by 2, 0 to pi minus x into sine 180 minus theta is going to be sine theta. Therefore, it is sine x. Denominator 1 plus cos square pi minus x. So 1 plus, that will also give you cos square x dx. Again add the two i's. So you get 2i is equal to, now sine x is common in the numerator. So we will take x and pi minus x in the bracket by taking sine x common. So integral 0 to pi, in the brackets you have x plus pi minus x into sine x divided by 1 plus cos square x dx. So x and x cancels to give you pi sine x by 1 plus cos square x. Now integrating this, you have to put a substitution. I've used cos x is equal to t. So differentiating, you get minus sin x dx is equal to dt. Now when I'm doing a substitution, I have to change the limits. So when x is 0, cos 0 is 1. So when x is 0, t is equal to 1. And when x is pi, cos pi is minus 1. So x equal to pi gives t is equal to minus 1. So when you see these limits, x is equal to 0, t is 1, x equal to pi, t is equal to minus 1. So now the new limits will actually be from 1 to minus 1. And numerator we have only sin x dx, but we need minus sin x dx, that should be replaced by dt. So for this minus sign, I will interchange the limits as 1 to minus 1 will become minus 1 to 1. And therefore, the new integrand will be integral minus 1 to 1 pi dt divided by 1 plus t square. Now this is, we'll use another property here. Minus a to plus a will become 2 times 0 to a for even function. So here this 1 by 1 plus t square is an even function, and therefore integral minus 1 to 1 can be written as 2 times integral 0 to 1. Pi being constant is taken outside. So inside you have dt by 1 plus t square. Now integrating 1 by 1 plus t square, you get tan inverse t. So that gives you 2 pi tan inverse t, limits varying from 0 to 1. Upper limit gives you tan inverse 1, which is 45, that is pi by 4. Lower limit gives you 0, so tan inverse of 0 is 0, and therefore this reduces to 2 pi into pi by 4. And 2i is 2 pi by into pi by 4, so bring that 2 down, and therefore I reduces to pi square by 4, which is your final answer. Let's go to the next problem, third problem. Evaluate integral 0 to pi by 2 x dx divided by sin x plus cos x. I call this integral again as I, and as usual we apply the property. Now the upper limit is pi by 2, so x will be replaced by pi by 2 minus x. So I is equal to integral 0 to pi by 2. Instead of x, you write pi by 2 minus x, and denominator is sin pi by 2 minus x plus cos pi by 2 minus x dx. So you add the two integrals now, and denominator here now changes to cos x plus sin x, and denominator is same for both the I. So you add the two to get 2i is equal to integral 0 to pi by 2. Numerator is x plus pi by 2 minus x divided by sin x plus cos x into dx. X and x cancels, leaving just pi by 2 in the numerator, which is a constant. You can remove it out. Now divided by 1 plus sin x plus cos x. Now to integrate this, we make a substitution. Put tan x by 2 is equal to t. Then dx will reduce to 2 dt divided by 1 plus t square. And sin x will be given by 2 tan x by 2 by 1 plus tan square x by 2. So you get it as 2t by 1 plus t square. Similarly, cos x is equal to 1 minus t square by 1 plus t square. We are just using our trigonometric formula where sin and cos are represented in terms of tan. So now replacing here, 2i is equal to pi by 2 integral. And as usual, substituting my limits. Like when you put x is 0, tan 0 will be 0, so lower limit remains to be 0. And when you put x as pi by 2, tan x by 2 will become tan pi by 4, tan 45, that means value is 1. So upper limit becomes 1. So numerator, that pi by 2 is taken outside, and here we have sin x plus cos x. So denominator for both of them is 1 plus t square, which will come to the numerator, and denominator will reduce to 1 minus t square plus 2t into, for dx you replace it as 2 dt by 1 plus t square. Now this 1 plus t square and 1 plus t square cancels. This 2 and this 2 cancels here. So just leaving you with pi integral 0 to 1. Now here you have a quadratic in the denominator with a minus t square. So we try to do a completing the square, which means I remove the minus sign for t square and 2t. So I'll have 1 minus, in the brackets you write it as t square minus 2t. When you complete the square, you can rewrite it as t minus 1 the whole square, which means I'm adding a constant, so I should subtract a constant. Then t minus 1 whole square and subtracting a constant with a minus sign outside will make that as positive 1, and that 1 gets added to this. So on completing the square, it reduces to 2 minus t minus 1 the whole square. If you have any doubt, you can expand this and see, because if you expand this t minus 1 whole square and simplify this, you should get back this 1 minus t square plus 2t. So now you have pi integral 0 to 1 dt by 2 minus t minus 1 the whole square. Now t minus 1 is treated as a single factor because t does not have any coefficient, so you can treat it as a single factor. It is in the form of 1 by a square minus x square, which will reduce in terms of log, where you have your formula for that, and using that particular formula I am directly changing as I is equal to, which means I am bringing down the 2 here, so that will give you I is equal to pi by 2 outside, and your formula is going to be 1 by 2a log of a plus x by a minus x. So 1 by a is going to be root 2 for us. So 1 by 2 root 2 log of root 2 plus, instead of x you have t minus 1 divided by root 2 minus t minus 1, and limits varying from 0 to 1. Now you substitute upper limit. When I put t as 1, t minus 1 will become 0. So this factor will be 0, giving you log of root 2 by root 2, which means it is 1. So log 1 value is 0. So upper limit value is going to be 0. Substituting your lower limit, when you put 0, you get root 2 minus 1 divided by root 2 plus 1. So the lower limit, you have a minus sign, so that minus sign is here minus pi by 4 root 2 log of root 2 minus 1 by root 2 plus 1. Generally in the exam, we do not like a root sign in the denominator, so we normally multiply this by the factor root 2 plus 1 by root 2 plus 1, so that your denominator here changes, and that will change and give you, I have taken it as root 2 plus 1 by root 2 plus 1. Here I have changed the negative sign, so the denominator and numerator can be interchanged. So it becomes root 2 plus 1 the whole square, which is in the denominator here, comes to the numerator, and root 2 minus 1 into root 2 plus 1 is a minus b into a plus b, which is a square minus b square, to give you 2 minus 1, which is 1. So removing the negative sign, it reduces to pi by 4 root 2 into log of root 2 plus 1 the whole square. That power comes down, so you can bring the 2 down, and that 2 and 4 cancels to give you a final answer as pi by 2 root 2 log of root 2 plus 1. Generally such problems, they might ask you to say prove that this integral is equal to this value, so then you must be able to do the simplifications here. So we'll stop here and continue in the next episode. Thank you.